we've already talked a lot about the idea that integral means area under the curve. That's where we started with integrals. And so, just kind of talking about a little bit more, the definite interval can be interpreted as the net area, right? And we had one of those on our quiz. Because if you have something where it's the same amount above the x-axis as below the x-axis, then the net area, or the integral value, is going to be 0, because the positive and the negative cancel each other out. So net area, or net distance traveled, can be 0. But we can also talk about the total area of just how much area is there if we disregard that some of it's negative. Your book says this. I'm not a big fan of your book saying this, that the unmodified word area will be taken to mean total area. I think that's a lie, because it says find the total area. On the AP test, they always say find the total area if they want you to find total area as opposed to net area. So put that in there just because it says that in your book, but I'm going to always say find total area. So if you were doing this analytically, that means without the calculator, without Math 9, you have to think about where does it change from positive to negative, which means you have to figure out the zeros of that function. Because if I had a function, right, you have to partition it up by the zeros, and you're going to find the area or the integral for each section, and you're going to disregard the negative, which means how do we do that in math? There's a value of each section, so that you get all positive values. Well, whatever that happens to be. Oh, this is really nice. With our calculator, all you have to do is tell the calculator to take the absolute value of a function. Isn't that amazing? So, this is the old school talk. R button is Math 9, and instead of just writing a function, they're going to do the absolute value of the function. And then you'll do comma x, comma a, comma b. There are questions. There have been questions on the AP test. Pre-response, right? This is like parts A, B, C, D. One of the parts will say find the total area or find the total distance traveled, which is the same idea. It's a calculated question, which means you have to show what you're actually like, show the actual integral that you would write. You have to show that, and then you type it in your calculator, and you write the answer, and you get a point, or sometimes 2 points, for knowing what that means. And so, definitely we want to know how to use the calculator, but then there's also going to be stuff that you have to do without the calculator as well. So, I'll do the easy part first. So it says, use the calculator to find your total area of the region between the curve y equals x cosine 2x and the x-axis over the interval from -3 to 3. So, do you all know where the absolute value button is? Yes. I always go to catalog because it's alphabetical order. That's the first one. But it's also in math. If you go over math, and you arrow over once. But if you ever forget where a button is during a test, catalog, which is second 0, absolute value is 3. So, but it works too. So, I want you to do more on your homework than just write the answer. I want you to rewrite the integral too, alright? So on our paper here, we're going to write the actual math piece here. So we're going to evaluate this from -3 to 3. Absolute value of x cosine 2x. Never in your life on a test do you write what you typed in on your calculator. You don't write math speak as work on calculators. You write the actual math. That for the new calculators, I still have an advantage. Like it looks like what we write. So it's like absolute value. And I guess on our calculators, it actually says APS. We're going to do x cosine 2x. I think the hardest part with calculator stuff is making sure the symbols are correct. Making sure you close parentheses when you should. Okay, so we would close the parentheses for the 2x, We would close the parentheses or the absolute value. Then we would put comma x, comma -3, comma 3. Remember, we're using a calculator. When we're going in decimals on the AP test, you must give me 3 decimals on the AP test if this was worth a point, and you said 5.42. Where do you get the point? It's 0. There's no partial credit for not rounding there. So we have to make sure we're rounding the 3 decimal places. So we're going to say this equals 5.42. Round to get that 5. Okay, so that's one of the ones that but also we want to do the ones without. So it says find the total area of the region between the curve and the x-axis. So y equals 3x squared minus 3 from -2 to 2. Step 1, you gotta find the zeros of that. So not a calculator. So how do we find the zeros of something? You set it equal to 0. The zeros are when, right, when y equals 0, when it crosses the x-axis. So, so you don't really have to graph it, right? Without a calculator, you could. This is just a quadratic. It's not that hard to graph. There's no need to graph it because we just need to know where to set up our integral. So we're going from -2 to 2. So we know that's in there. And we're going to stop at each 0. So also we're going to break that up at -1 and 1. Which means how many integrals do I have here? How many different regions of my graph? Like would it I have to do -2 to -1, but then I'm going to stop at -1 because then it's going to cross the x-axis again. And then I'm going to add that to the integral from -1 to 1, and then I'm going to add that to the integral from 1 to 2. Definitely more work than with the calculator, right? So you have to break it up like that. And for each of these, the great thing is it's the same function every time. So once you do the antiderivative once, you have to do it every time. I've already done it. Like all of them are the integral 3x squared minus 3. Which means once we do the antiderivative once, we're going to get x minus 3x. Stay with me, Grady. Now we just have to evaluate it for each one of these. And remember, we're really taking the absolute values of this. Okay, so it's not the absolute value at the end, because if you take the absolute value at the end, nothing's going to change. It's the absolute value of each little section of the graph, so that way that you're like disregarding if it's below the x-axis. So I'm going to do this from -2 to -1, and I'm going to add that to the absolute value of x cubed minus 3x evaluated from -1 to 1. I'm going to add that from the absolute value of 1 to 2 to 10. Again, this would be on a no calculator part, so we have to calculate stuff. So I'm going to take my calculator. 1 plus 3 minus 2 in there, negative 8. Right, so I'm kind of doing it different this time. The last couple days we've done this, I keep my minus out front, I put parentheses. And I'm going to do the same thing from negative 1 to 1. So that's just negative 1. Minus 3 minus the negative 1 plus 1 and then minus 3. Really easy enough to negatives. I hope you're trying to think of this on your own. Check to see if I'm doing it correctly. And then my last one, I do the same thing from 1 to 2 to the absolute value of 8 minus 6. Minus 1. Probably the biggest mistake that happens like this is people want to make the absolute value of the variance. But the other mistake is it's just easy to make negative or for multiplication mistakes as we're doing this. So, negative 7 and 11 and 4. And this one. This one. 4, right? It's absolute value. Four. So, just to kind of think about this, this was really the absolute value of 4 plus the absolute value of negative 4 plus the absolute value of 4, which means that our net area would be different than our total area because some of that was negative. So our total area answer is 12, where if the question just said the net area, that would be right. See, look, adding is hard. And again, you can actually graph it if you want and pick some points and actually see the quadratic there. But the idea is you don't have to graph it. If you just did the integral by hand from negative 6, you can get the net area. So you can get the wrong answer if you don't break it up by the zero. And our multiple choice questions are always going to have that as well. So you have to remember it. Okay, and then there's some really cool ones on your homework giving you pictures of graphs, and so I wanted to look at a couple of those. So this is number 46 on page 3. Know that. The question just there says find the area of the shaded region, and they give you the equation, right? So this is from this is the square root of x. But then it starts with x squared, so it's kind of like a piecewise function that the functions come together. So we can take this idea of breaking up integrals. We could just do this. It's just going to be two different integrals in the same problem and adding them together. So I can kind of break this up, right, as two separate graphs and two separate integrals. So I can do the integral from 0 to 1. And that's just going to give me that little chunk. So then I need to add that to integral from 1 to 2 of just x squared. And again, I want you writing this stuff out. I don't want you starting with the integrals and the antiderivatives. I want you showing me what you're setting up in the problem, because you get points for that. It's not that bad. Just have some more practice there. 1/2, the antiderivative of that. Do we need absolute value on this one? Because what? It's all positive. It's all above there, right? And so just find the area of the shaded region. You don't need to do absolute value. What was the antiderivative of this piece? If I add 1 to that, that's x squared half. So if I have 1. And then this one's not so bad, right? Add 1 and divide by that. So that's this x is 3 from 1 to 2. And again, this is the notation that you need to use. My 0 looks like a 2. So now if I plug that in, I'm just going to get 2/3 minus 0 plus 8/3 And again, I'm fine with you checking this stuff with your calculator, but this could be stuff. This is not that hard of arithmetic that could be expected for you to do on the test without a calculator. That's just 0. 1 to anything is just 1. That's just 2/3 plus 8/3 minus 1/3, which is just 9/3, which is really just, okay, that's perfect. That's it. It's just great. Alright, what about the next one? I want you to think about this one first. This one says, again, find the area of the shaded region. So I don't know if you can see the shaded region on yours as well as you can see it up here. But the shaded region is just this part of the graph. So we want to think about how could we set up an integral that we could find the area of the shaded. Semicircle will be, whoa, what is a semicircle? What if I did the integral of sine of x? Well, first of all, what would my bounds be? Definitely pi 6 to 5 pi 6. If I just did the function, they tell me this is sine. If I just did the integral from pi 6 to 5 pi 6, what would I be finding? What area would I be finding? I would be finding all of this. Right? Like just from pi 6 to 5 pi 6. Oh, and so the part that we don't want happens to just be a rectangle? Could I then just subtract out the area of that rectangle? Right? Remember, area and integrals kind of mean the same thing. So I could take minus, I'm just going to put area. Take out the part I don't. So which one do we want to do first? The integral or the area of the rectangle? The integral, we're going to calculate, right? What's the integral of sine of x? Negative cosine, right? Because you need its derivative, it's antiderivative, so the derivative of negative cosine would be positive sine. And I'm going to leave that for now. We'll plug in the numbers in a minute. The area of the rectangle. So we need the length times the width or the height there. The length, do you agree, is just taking like the b minus a, so it's just 5 pi 6 minus pi 6. So, yes, 5 pi 6 minus pi 6, that's going to be like my length. But then I need to know how tall it is. How could you figure out how tall it is? How'd you get 1/2? How could you say, like, what if the graph wasn't drawn accurately? How could you know what that is? How did we find our height when we did, like, Riemann sums? Like, how do we know if we had this value? How do we know what the height of these is? Plug it into the function, right? So this is saying, what is the sign at pi 6? It's a half. It is a half. What about 5 pi 6? Is the sign of 5 pi 6 also a half? Yeah. So you're right. It's a half. So you're using the function value to do that. So now we have to do some more tricks. Negative cosine of 5 pi 6 minus negative cosine of pi 6 minus 4 pi 6 is 2 pi thirds. Okay. Told you can leave answers unsimplified on the no calculator part of the AP test on the not the multiple choice part, but the other part. But this doesn't count, right? Like, you have to work this out to be number values, so you wouldn't get credit if you left your answer like this, because you have to evaluate the trig function first. But then if you didn't want to combine like terms on the free response, you didn't have to. But if we know that the cosine, we know the sine of pi 6 is 1/2, which means the cosine of pi 6 is square root of 3 over 2, but 5 pi 6, it would be negative square root of 3 over 2, right? But it's already negative, so that's a whole lot of negatives. So it's negative of negative square root of 3 over 2 plus 3 over 2 minus 1/3. I really could leave it like that, but we could go, what's square root of 3 over 2 plus square root of 3 over 2? Sorry. Is that just square root of 3 minus pi 6? Wouldn't this be 2 square root of 3 over 2? If you added them together, just like x over 2 plus x over 2. Which means I think that's physics. Your calculator will give you that, right? Your calculator will give you that. Plus your calculator, you still have to subtract out the rectangle. Your calculator doesn't know how to do it. You could do the integral part, but you still have to do it. Right? That's some good things. I like Alright, so if you still have questions to do from yesterday that are you're just practicing your fundamental theorem calculus, you can finish that. And then we're adding these into 41, 43, and 44 are using your calculator. You just have to set that to your actual value. And then 45 and 47 are just like the ones we just did. It tells you can use your calculator on 51, 50, 51, and 54. So like half of these are calculator questions. 57 is some good, like going back to using power functions, like increasing, decreasing, acting and stuff, right? And we'll probably talk about 57 Carbo science. And I think that's important. On the true false multiple choice, it always tells you at the top whether or not you're using calculator. And this one says use A, use the graphic calculator. So I really think the only ones that are without the graphic calculator are 45 and 47, and maybe that's it. The rest of them are practicing just your graphic calculator. Seems like a good amount of problems, but a lot of practice there with your 67 is ACS, so look at it before you just copy out back and go. What's called the upper class using three problems, so each one has a part, and then each of those big parts there are two answers. So it looks like oh, it's four more parts here. Let's take the part from doing 100 addition backs in 5 minutes.